Here you as we are looking at the probability tree diagrams as one of the ways of ensuring that problems under probability are done properly, and it is also one of the ways of generating sample space. Previously we looked at conditional probability, and it is basically going to help us under this topic. Now, when you talk of probability tree diagrams, this is very much important in the probability or in the statistics, and we shall be able to solve questions that will follow. And this is how we are going to use a tree diagram. How to use a tree diagram. Now, when a tree diagram is drawn, you ensure that where the two branches meet, because we shall be doing and we get out tree diagrams, the two branches meet here, and probability here plus probability here, P1 plus P2 should give us 1. So that will be a check. Then, if a tree is extended, maybe to P3, P4, P5, then P6, and you will have to multiply P1 times P3, then P1 times P4 to get the end result, then P2 times P5 to get end result, to get P2 times P6 to get end result. So these end results, if at all a question is asked, you have to add after you have checked that they are correct. And in illustrating our topic today of tree diagrams, we are going to use our examples. We have got questions that are going to help us ensure that we understand this concept of tree diagrams. We have question number 1, which says that when Peter needs a bus, for transport in his company, it is he's hired from farms X, Y, and Z. So we have 3 farms X, Y, and Z. It means that if Peter needs a bus, then it must be from 3 companies. Now, if we are to draw a tree diagram, it means that you have to first get a company. Peter needs a company. That one comes first on the tree diagram. And we have got 3 companies or farms, X, Y, and Z. Now, X is able to give Peter 40%, and as a proportion, it is 0.4. Y is able to give Peter 50%, which is 0.5. While Z is able to give 10%, which is 0.1. And you will realize that these are 3 branches which meet at a point, and the sum is clearly 1. Before you proceed, you have to check that it is 1. Now, we have a question that we have a statement here that 4 buses had from X. For X, now you focus on X. 9% arrive late means that some buses will arrive late, others will not. So for X, those which arrive late, 9%, which is 0.09. These ones arrive late, and we define that as buses which arrive late, given that they are from X. So we are using the event error for arriving late. Now, meaning that buses may be from X, they may not arrive late, given that they are from X. And since we know that when you add here, you get 1, then you shall get 1 minus 0.09, giving us 0.91. 1 minus 0.09 gets 0.91. And we continue and see that The corresponding percentages for buses had from Y and Z, we have 6% and 20% respectively. So from Y, we have 6%. Those which arrive late, given that they are from Y, it is 6%, that is 0.06. Those which arrive early or which don't come late, given that they are from Y, it is 1 minus 0.06, which gives 0.94. Now, 20% from Z, those which arrive late, given that they are from Z, it is 20%, giving us 0.2. Those which don't arrive late, given that they are from Z, it means it is the reference, which is 0.8. Because the sum should give us 1. So, we have a question that calculate the probability that the next bus hire will be from X and will not arrive late. So, you come on your tree, you see, from X and not arriving late. From X, not arriving. So, this is similar to probability of X and not arriving late. And this is very clear that is the probability of X multiplied by probability of not arriving late, given that it is from X. So I say you multiply along that line. So we shall have 0.4 for X, then times 0.91, and this will give us a probability of 0.364. So that will be the probability the next bus hire will be from X and will not arrive late. If it was probability that it will be from X and will arrive late, we would have followed this one. But B will arrive late. Now probability that it will arrive late. This one is having a path either from X or Y or Z, because arriving late is general. So this one will be this part, and this part. And therefore we shall have probability of X times probability of arriving late, given that from X, or probability of Y times probability of arriving late, given that is from Y, or probability of Z times probability of arriving late, given that is from Z. So here we are multiplying as we add, as I told you. So it is a matter of multiply along the tree and you add. So we shall have finally 0.4 multiplied by 0.09. We add 0.5 multiplied by 0.06. Then you also add 0.1 multiplied by 0.2. When you compute with your calculator, you will realize that the sum of those three products will give us 0.086 as the probability of arriving late, irrespective of where the bus is headed from. Now, if we now go to question part C, the question is you calculate the probability that the next bus hire will be from Y, given that it arrives late. So that one brings us the other issue of conditional probability, that probability that the bus will be from Y, given that it will arrive late. and this is the same as probability of y intersection L over probability of L. Now, probability of y intersection L the same as probability of y multiplied by probability of L given y from our tree diagram over probability of arriving at which we already have. And this will be probability of y, which is 0.5 times probability of arriving at given, that is from y, which is 0.06, divided by probability of arriving at, which we have already computed as 0.086. Now, with your calculator, this will give us 0.5 times 0.06 divided by 0.086, and it eventually gives 0.3488 or 15 out of 43, and is better express probabilities as fractions as our best way of presenting probabilities. So that's how we can use a tree diagram attempt such a question. Now we have got question 2. So we are done with question 1. Now I want to look at question 2, and we use a tree diagram to answer this probability question, where it goes that events x and y are such that probability of x complement 3 out of 5. Probability of y given x complement a third. Probability of y complement given x is a quarter. And we say that probability of y given x complement means that event y occurs when x complement has already occurred. So when you are drawing a tree diagram, on your branches, you begin with the event which occurs first. And according to our question, x occurs first. So we can have x or x complement, x and its complement. So since we have the probability of x complement as 3 out of 5, and we say that to complete a branch, the total probability must be 1. That means that we shall get 1 minus 3 out of 5, which gives 2 out of 5. Now, what follows is y. Y follows x. So this is the probability of y given x. That x has already occurred, or y complement given x. Now you put the question and see what is given. It is y complement given x as a quarter. But still this is another branch. This is a quarter. This is another branch, and since the sum should be 1, it should be 3 quarters. Now, this is also probability of y given x complement, then the probability of y given x complement, and this y complement also. Now, what is given in the question is the probability of y given x complement, which is a third. So this will be a third. Then 1 minus a third gives 2 thirds. Then you go to the questions that using a tree diagram, find probability of y. Where are you finding y? Either here or here. So probability of y is having probability of x times probability of y given x, or probability of x bar times probability of y given x bar. This will give us probability of y, because it is either here or here. And this will be 2 out of 5 multiplied by 3 out of 4, and 3 out of 5 multiplied by a third. And and we shall have add these two, giving us this is 6 out of 20, 6 out of 20, add 3 out of 15. So if we add these two probabilities, we shall have 6 out of 20 plus 3 divided by 15, and it gives us a half or 0.5. It is better to reduce if you want, but you reduce after extracting them from the tree diagram. So that is how we can get probability of y, and on our tree you look at where the line of y lies, either here or here. Then part B, probability of x bar given y. Probability of x bar given y, here we don't have, but we can say that this is the same as probability of x bar intersection y over probability of y. But probability of x bar is probability of the complement of x times y. And on our tree, we have probability of x and y. But we need x bar and y. So which is probability of x complement intersection y. But to simplify it further, we can say that this is the probability of, let me use, if this is x and this is y, this will be x complement intersection y. Meaning that it is the probability of the y, it is the probability of y, you take away probability of the intersection, which is the probability of x and y, over probability of y. And probability of y, we have it as a half, minus x and y, which is 2 out of 5, multiplied by 3 out of 4, all this over 0.5, and we shall have 0.5, we take away 6 divided by 20, 6 divided by 20, and that is 0.3, divided by 0.5, this is 0.2, over 0.5, and it gives 2 divided by 5 as our simple probability of x bar given y. So this is the simple way of expressing it, and that's how what we can talk about our probability tree diagrams. And you can have the third question just interpreted, and you'll be able to try it out. As question 3, we have that in a certain selection of seeds to farmers during this period of COVID, 2/3 have been treated to improve germination, and 1/3 have been left untreated. Meaning that before these seeds are to be planted, they have to be treated. So on your tree diagram, you have to begin with the issue of treating the seeds. We are going to use an event T for treating, then T complement seeds which have not been treated. And it is very clear that 2/3 have been treated. 2/3. Meaning that even if you have not been given those which have not been treated, you get 1 minus 2/3, which gives 1/3. Now, you treat seeds, and either they are grown and germinate, that is germinate, or they fail to germinate. Or they are not treated, and when they are grown, they germinate, or they don't germinate. So those are the two issues that you have to look at after treating the seeds. You move on, the seeds which have been treated have to germinate, and their chance is 0.8 if they are to germinate. That means this should be 0.8. Failure to germinate, 0.2 for those seeds which have been treated. Those which have not been treated, they have a chance of germinating of 0.5. Those who have not been treated, it is 1 minus 0.5, which is the same as 0.5. Now, when the question says, find the probability that a seed selected at random will germinate, you come here, see where there is a word, where there is letter G, germinate, or so they will germinate whether they are treated or not. So you get 2 out of 3 times 0.8. 2 out of 3 times 0.8. This will be the first output, or a third times 0.5, and you get the second output, which are added together to get probability that the seed selected will germinate. Okay? Now, find the probability that a seed selected at random had been treated, given that it had germinated. So meaning that for part B, you will be able to see the probability. There is a condition given that it had been sown, or it had germinated when sown. So probability that a seed selected, find the probability that a seed selected at random had been treated, given that it germinated. So this is probability of T, the section G, over probability of G, where G is probability of germination, which you would have already gotten here. Then treated intersection G, it is treated, it is only this part, which will be 2/3 times 0.8 divided by probability of germination will be 2/3 times 0.8, or a third times 0.5. And when you compute here, you will be able to get the probability of having a seed that germinated when it was first treated. So, using this knowledge, you should be able to attempt questions based on these three diagrams. Thank you very much.